This is a research brief for the original 1989 Management Science article, which discusses the merits of the technology acceptance model in comparison with the more general theory of reasoned action. Investment in business technology is inherently risky. Their complexity, scope, and cost all add up to a major investment of both time and money that is not even guaranteed to work. Oftentimes, when the project is actually completed, it is still underutilized or resisted by end users. This resistance to end-user systems by managers and professionals is a widespread problem that needs to be addressed. Why is there so much resistance to new technology? What makes us so averse to change? These are compelling and often difficult questions that need investigation, but existing research has fallen short of conclusiveness. Understanding why people accept or reject computers and related technologies has proven to be one of the most challenging issues in information systems research. In this study, we hope to better predict, explain, and increase user acceptance through a better understanding of why people reject or accept computers. Furthermore, this research addresses the ability to predict people's computer acceptance from a measure of their intentions and the ability to explain their intentions in terms of their attitudes, subjective norms, and perceptions of the technology. The results of this study suggest the possibility of simple but powerful models predicting user acceptance of technology, with practical value for evaluating systems and guiding managerial interventions aimed at reducing the problem of underutilized computer technology. This model, called the Technology Acceptance Model, is a powerful framework that can be used to help both researchers and practitioners learn how to develop better information systems. In order to understand TAM, we must first look at the theory of reasoned action, which is a widely studied model from social psychology, which is concerned with the determinants of consciously intended behaviors. TRA is a general model, and as such, it does not specify the beliefs that are operative for a particular behavior. Researchers using TRA must first identify the beliefs that are salient for subjects regarding the behavior under investigation. From an IS perspective, a particularly helpful aspect of TRA is its assertion that any other factors that influence behavior do so only indirectly by influencing attitude or subjective norms. In 1986, Fred Davis introduced an adaptation of TRA, the Technology Acceptance Model, which is specifically intended to explain computer usage behavior. The goal of TAM is to provide an explanation of the determinants of computer acceptance that is general and capable of explaining user behavior across a broad range of end-user computing technologies and user populations. This study is motivated by four main research questions. First, how well do intentions predict actual usage? Second, how well do TRA and TAM explain intentions to use a system? Third, do attitudes mediate the effect of beliefs on intentions? And fourth, is there some alternative theoretical formulation that better accounts for observed data? In order to assess TAM, we gathered data from 107 full-time MBA students who were invited to use a new computer technology. At the beginning of the semester, the students were given 1 hour of training and orientation on the use of the new technology. At the end of this training, we administered the first wave of a questionnaire containing measures of the TRA and TAM variables. 14 weeks later, we administered the same questionnaire and additionally inquired regarding their actual usage of the new technology. Our results yield three main insights concerning the determinants of computer use. First, people's computer use can be predicted reasonably well from their intentions. Second, perceived usefulness is a major determinant of people's intentions to use computers. And third, perceived ease of use is a significant secondary determinant of people's intentions to use computers. What do our results imply for managerial practice? When planning a new system, IS practitioners would like to be able to predict whether the new system will be acceptable to users, diagnose the reasons why a planned system may not be fully acceptable to users, and to take corrective action to increase the acceptability of the system in order to enhance the business impact resulting from the large investment in time and money associated with introducing new information technologies into organizations. While attempts to solve this problem have been made with the use of early warning techniques, there has been the lack of good predictive models that can be used to help improve these techniques. Rapid prototypes, user interface management systems, and video recorded mock-ups are increasingly being used to create realistic facades of what a system will consist of at a fraction of the cost of building the complete system. Though this raises the question of whether a brief exposure to a prototype system is adequate to permit the potential user to acquire stable, well-formed beliefs. Our findings indicate that after just 1 hour of training and orientation, people formed general perceptions of a system's usefulness that were strongly linked to usage intentions, and their intentions were significantly correlated with their future actual usage of the system. Our findings have implications for improving user acceptance as well. Many designers believe that the key barrier to user acceptance is the lack of user-friendliness of current systems, and thus, increasing a system's ease of use is the key to success. Yet, our data indicates that although ease of use is clearly important, the usefulness of the system is even more important and should not be overlooked. Although users may be willing to tolerate a difficult interface in order to access functionality that is very important, no amount of ease of use will be able to compensate for a system that doesn't do a useful task. Such an implication should help guide software design decisions. However, future research is needed to further test the generality of the trade-off between usefulness and ease of use. Overall, research in this direction should yield practical techniques to evaluate and improve the acceptability of end-user systems. The ability to take robust, well-informed measures of the determinants of user acceptance early in the development process is undoubtedly going to have an impact on our ability to weed out bad systems, refine the rest, and generally cut the risk of delivering finished systems that get rejected by users.